Hi, my name is John Thompson, and we're going to be doing a presentation today on orienteering and map reading. We're going to be taking a look today at scaffolding of knowledge. The particular example that we're going to show here is Webb's depth of knowledge. Now, we're going to take a look at the knowledge itself. What exactly is the knowledge? Well, we're going to be using a map and navigational aids early and modern. What's our application of that knowledge? What's it used for? We're going to be using it to find safe routes for errands and finding a position on the globe. Reflection, why are we learning it? We're learning this to prevent ourselves from getting lost. We're learning that technology is not always reliable, and we're going to be learning an extension of that knowledge. How else is it used? It's a requirement for captain's or pilot's license. Military personnel use it, as well as first responders and building trades. And lastly, we're going to be looking at brainy bits. We're going to be looking at emotions and learning, what to do and what not to do when you get lost. We're also going to be looking at what you don't do when you're walking, which is basically respecting people's properties, respecting fences, as well as staying off of railroad tracks and railroad safety. Here we are at the objectives part of our lesson. Students in the 10th through 12th grade will learn the following in about 4 to 5 days. They're going to learn Earth coordinates. They're going to learn navigational aids and their use. They're going to learn how navigational aids work. They're going to learn what to do if lost. They'll learn railroad safety, how to plan a route. They're going to understand the terms used in the lesson, and they're going to understand why and where redundant means of navigation are used. Here are the instructional materials we're going to be using for this lesson. We're going to be using Google Slides to illustrate the concepts before doing the hyperdoc activity. In this slideshow, there will also be questions the students will answer. There will be a Google Map link and a hyperdoc with questions pertaining to that Google Map. We will also have YouTube videos to explain how to use navigational aids, and lastly, an assessment will be included in Google Forms. Here we are at our lesson introduction. We're going to be taking a look at what exactly is a map today, and in understanding that, we're going to have to take a look at what maps used to be. Maps used to be paper, and they used to only contain the information that was printed on them. Nowadays, maps tell us more than just what's printed on with the technology and technological devices. Maps tell us the following. They'll tell us the place on Earth, the relationship to features like rivers, lakes, mountains, and oceans, buildings and their relationships to roads and other objects, boundaries, borders and property lines, transportation routes, infrastructure and facilities, topographic elevations and land contours, and lastly, how to go from place to place. Here we're going to be looking at Earth coordinates. We're going to be looking at the concepts of longitude and latitude. In the diagrams below, you're going to see lines of latitude on the left displayed, which are horizontal lines ranging from 0 to 90 degrees at the North Pole and 0 to negative 90 degrees at the South Pole. On the right, you're going to see the prime meridian. The prime meridian is at 0 degrees and runs from pole to pole. Now, those lines are going to run east to 180 degrees, which is also known as the international date line. And those values that run east are going to be positive, and the values that run west are going to be negative. In this slide, we're going to be taking a look at how Earth coordinates are shown. Earth coordinates are listed as latitudes and longitudes, yet not every coordinate is listed in perfect degrees. Degrees, like any other measurement, have fractions to identify them. Degrees can be either latitude or longitude. Longitude and latitude are needed to get your position on the Earth. These are fixed points on Earth. Think of them as X and Y when graphing. Minutes, like a clock, there are 60 minutes to a degree. 33 and an apostrophe equals 33 minutes. Keep in mind that 1 minute is 1 mile. Seconds, again as in a clock, 60 seconds are in a minute. 5 with quotation marks equals 5 seconds. Here's an example. We have the Arctic Circle at 66 degrees, 33 minutes, and 44 seconds north. And conversely, we show the Antarctic Circle at the same measurement, but it's a negative value. Latitudes run north and south. Both have 90 degrees and terminate at the equator, which is 0 degrees. Longitudes run east and west. They range from 0 to 180 degrees with the same positive and negative values. At the prime meridian, 0 degrees longitude becomes the international dateline at the poles, and west is listed as a negative value. Degrees can also be shown decimally. Positive and negative also apply. Here you have again the Arctic Circle at 66.5622 degrees, and converse to the Antarctic Circle with the negative value. Now keep in mind that decimally 33 degrees would be the 33 divided by 60, which would give you the 0.56 measurement. We're going to be looking at some navigational aids and methods. Pictured here are some early examples of navigational aids. We have the compass, the marine sextant, celestial navigation, and the astrolabe. You will notice that some of these methods are still used in tandem aboard ships with electronic methods. Here are some more navigational aids and methods that are continued. We're going to be looking at some modern examples. We have Loran-C, a Magellan GPS, a radiomagnetic indicator, and smartphones. For this particular part of the presentation, we're going to be talking about exercises and a map activity. There is a map link on this slide as well as a hyperdoc. Both are related to each other, and questions about the map will be answered on the hyperdoc. There will also be additional questions that the students will have to answer on this slide. They're going to have to pick an early navigational aid and describe how it works. They're going to research it online and describe the principles of how it works in a couple of paragraphs. They're also going to pick a modern navigational tool, research and explain how it works, and write a couple of paragraphs on that as well. They're going to explain why early navigational aids would be important to mariners. They're going to understand what concepts still apply to both modern and early navigational aids, and they're going to understand why Earth coordinates are important. And they're also going to look at what else they can do if they were lost from the Brainy Bits reading. Here are some important terms to learn. We're going to take a look at each one of them. We're going to take a look at a cartographer. A cartographer is a person that makes maps. We're going to understand what a chart is. A chart is the same thing as a map, but it covers large areas of water instead of land. We're also going to be talking about dead reckoning, which is in the extension part of the hyperdocument. Dead reckoning is figuring out what your position will be at a given time. We're going to be talking about declination, which is in the hyperdoc as well, and talking about how to use a map and compass together. It's the angular deviation of a compass needle from true north. We're also going to be talking about fathoms. Fathoms are a unit of measure for depth that are shown on nautical charts. 1 fathom is equal to 6 feet of water depth. We're going to be talking about GPS, an electronic means to determine your position on the Earth through satellites. We're going to be also talking about knots. Knots are 1 nautical mile per hour, which is equivalent to 1.15 miles per hour. We're going to be talking about navigational aids. We're going to be talking about paper streets, streets that are shown on a map but not yet built. We're going to be talking about the sextant, trip chaining, which is part of establishing an efficient route of travel using all the destinations in one direction, a radio directional finder, using radio signal origins, as well as sonar, which is the use of sounds and echoes to navigate.